In this homework assignment, we asked you to write a function called autodebug, which takes a test piece of code, a test list, and a test interesting, which checks if a code is interesting in some way. What we really mean is if there's some kind of bug that we know is going to happen. So we have this test specifically to check for it. In this case, the test is interesting if it contains a plus b on the same line and variable a and variable b before that line. So how do we go about doing this? Well, we first take the actual test list and the interesting test itself, and if test itself is not interesting, then we return none, because if it's not interesting, none of its subsets are going to be interesting either. Otherwise, we continue on and we set a size and a current test, best size and best test, to be the length of the current test and test itself, because we know those are interesting since we didn't return, and we want to hopefully find a smaller subset so that we can narrow down where we are and where the bug we care about actually is. So we run through all the subsets of test, and I'll go through how we implemented that in a second. And for every element smaller in all the possible subsets of the test list, we check if, first of all, the length of this subset is less than the current best size, the current size of an interesting test list, and that this element is also interesting. If it is, then we reset the new best test to be this smaller subset, and the current best size to be equal to the length of this smaller subset. And we keep running through this until we find, hopefully, the smallest subset or a smallest subset. We might have two interesting subsets that are the same size. That's possible. And then once we are all done with checking through all possible subsets, we just return the best test. Now, to get all the subsets, which is something called a Powerset, if you're familiar with set theory, we run it through this other function called allSubsets that takes a list, sets an element called Powerset, or pset, that is a list containing just the empty list, because the empty list is always a subset of everything, because it's nothing. And for every element in the list, we add to pset for all x that are currently in pset, that plus the element we're talking about. And this is really something that you should probably play with and see how it acts to really buy that this does what it says it does. It's a really clever piece of code. And then we just return this. And this is just all the possible subsets, including the set itself. So what the allSubsets method really does is it takes a list, let's say list 1, 2, 3, and it returns all of the subsets of that list. So we would have the empty list, and we'd also have the subsets containing just one element, and then all the subsets containing two elements, or sublists. I keep saying subsets. Really, these are lists, and it's not strictly the same thing, but we can treat them like that for now. And then all the subsets containing three elements, which is actually just the overarching list itself. And this is what the function allSubsets returns. Now, to test this, we have a few test cases down here, and we already had the interesting test that we talked about earlier, and we run test1 through that, and test1 is this fragment of code up here. So variable x, variable y, variable z, x equals y plus z, y equals z, and z equals x plus x. So we run that through autodebug, and we should find that this is the smallest interesting fragment. And we see the first true statement means that this is true. You find another interesting test, and for this one, it's just a list is interesting if it contains three numbers in strict ascending order. And then we take some numbers here that we have generated somewhat randomly, and we check autodebug against test2 and interesting 2. And just by hand checking this, you should see that the length of the smallest interesting subset is 3, which we can see when we ran it, we got true. And indeed, if we check if the answer from this is itself interesting, if we run it back through interesting, we see that it is true. So our function for auto-debugging, or at least some auto-debugging, works fairly nicely.